Encountering DIY wiring disasters post-contractor work is an unfortunate but real scenario. This can lead to failed inspections and potential safety hazards. Let's explore how to navigate this tricky situation. Firstly, assess the damage. Thoroughly document the extent of the homeowner's DIY work. Pay close attention to its potential impact on the safety and structural integrity of the home's electrical system. Take photos and videos, noting any code violations, unsafe wiring practices, or potential fire hazards. Secondly, communicate with the homeowner. Initiate a calm and professional conversation. Explain the issues you've identified and emphasize the importance of using qualified, licensed contractors for electrical work. Highlight the potential dangers of unpermitted or improperly executed electrical modifications, referencing local electrical codes and safety standards. Thirdly, request a re-inspection. Once you've rectified the homeowner's mistakes and ensured the electrical system meets code requirements, schedule a new inspection with the electrical inspector. Provide them with documentation of the corrections made and be prepared to answer any questions they may have. Consider legal options. If the homeowner's actions have caused significant damage, created serious safety concerns, or refused to cooperate with necessary repairs, you may need to consider legal recourse. Consult with an attorney experienced in construction law to explore your options, which may include filing a claim for damages or seeking an injunction to prevent further unauthorized work. To prevent future occurrences, you can take several proactive steps. Firstly, set clear expectations. Incorporate a clause into your contract that explicitly prohibits homeowners from attempting any DIY electrical work after you have completed the job. Provide this information in writing, emphasizing the potential risks and liabilities associated with unauthorized modifications. Secondly, document your work. Take photos or videos of your finished work before leaving the job site. This provides valuable evidence of the condition of the electrical system upon completion and can be used to refute any claims of pre-existing issues. Thirdly, communicate with inspectors. Keep inspectors informed of any potential issues or delays that could give homeowners the opportunity to make unauthorized changes. This proactive communication can help prevent problems from arising in the first place. Provide homeowners with educational resources. Share information on the importance of hiring qualified professionals for electrical work. Explain the potential consequences of improper wiring, including fire hazards, electrical shock, and damage to appliances and equipment. Refer them to reputable sources of information such as the Electrical Safety Foundation International or the National Electrical Manufacturers Association. When assessing the homeowner's work, look for several common mistakes that DIYers often make. This could be improper wire connections. Ensure all wire connections are secure and properly insulated using wire connectors or tape. Loose or poorly insulated connections can lead to arcing, overheating, and fire hazards. Check for overloaded circuits. Verify that circuit breakers are properly sized for the loads they serve and that no circuits are overloaded with too many appliances or devices. Overloaded circuits can cause breakers to trip frequently and increase the risk of fire. Examine grounding and bonding. Confirm that all electrical equipment and appliances are properly grounded and bonded to prevent electrical shock hazards. Check for proper wiring methods. Ensure that all wiring is installed in accordance with the National Electrical Code 300 and local electrical codes, using appropriate wiring methods and materials for the specific application. Look for unprotected wiring. Verify that all wiring is properly protected from physical damage using conduit, cable trays, or other approved methods. Unprotected wiring is vulnerable to damage and can create a safety hazard. Check for improper use of extension cords. Educate the homeowner about the dangers of using extension cords as permanent wiring and ensure that they are used only for temporary applications. Now let's delve deeper into specific areas of concern and code requirements. Firstly, grounding and bonding are critical for electrical safety. The purpose of grounding is to provide a low impedance path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. The grounding electrode system typically consists of a ground rod, ground plate, or connection to a metal water pipe. The grounding electrode conductor connects the grounding electrode to the equipment grounding bus in the service panel. Bonding, on the other hand, connects all metal parts of the electrical system together to ensure they are at the same electrical potential. This includes metal conduits, metal enclosures, and metal equipment frames. Bonding minimizes the risk of electrical shock by preventing voltage differences between metal parts. According to NEC 250, all metal parts of the electrical system must be bonded together using approved methods, such as bonding jumpers or bonding screws. Secondly, overcurrent protection is another critical aspect of electrical safety. Circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. When the current in a circuit exceeds the rated capacity of the breaker or fuse, it will trip or blow, interrupting the flow of electricity and preventing damage to equipment and wiring. NEC 240 provides detailed requirements for overcurrent protection, including the proper sizing of breakers and fuses, as well as the types of overcurrent devices that are permitted for different applications. It's important to ensure that circuit breakers and fuses are properly sized for the loads they serve and that they are in good working condition. Thirdly, wiring methods are also specified by the NEC. The NEC outlines various wiring methods that are permitted for different applications, including non-metallic sheet cable, armored cable, conduit, and cable trace. Each wiring method has its own set of requirements for installation, support, and protection. For example, non-metallic sheath cable, commonly known as Romex, is often used for residential wiring. It must be supported at intervals not exceeding 4.5 feet and protected from physical damage where necessary. Conduit, on the other hand, provides a higher level of protection for wiring and is often used in commercial and industrial applications. Different types of conduit are available, including rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Fourthly, box fill calculations are essential to ensure the safe and proper installation of electrical boxes. NEC 314 specifies the maximum number of conductors, devices, and fittings that are permitted in an electrical box based on its size and type. Overfilling electrical boxes can lead to overheating, damage to conductors, and potential fire hazards. The box fill calculation takes into account the volume of the box, the number and size of conductors, the number of devices, such as switches and receptacles, and the number of fittings, such as connectors and clamps. It's important to perform accurate box fill calculations to ensure that electrical boxes are not overloaded. Fifthly, arc fault circuit interrupters or SIs are designed to protect against arc faults, which are a common cause of electrical fires. Arc faults occur when electricity jumps between two conductors, creating a spark or arc. SIs detect these arc faults and quickly interrupt the flow of electricity, preventing a fire from starting. NEC 210.12 requires SIs to be installed in branch circuits that supply bedrooms, living rooms, dining rooms, and other areas of the home. SIs are an important safety device that can help prevent electrical fires and protect occupants. Sixthly, ground fault circuit interrupters or GFCIs are designed to protect against ground faults, which occur when electricity leaks to ground. Ground faults can cause electrical shock and are particularly dangerous in wet locations such as bathrooms, kitchens, and outdoor areas. GFCIs detect these ground faults and quickly interrupt the flow of electricity, preventing electrical shock. NEC 210.8 requires GFCIs to be installed in bathrooms, kitchens, garages, and outdoor areas, as well as other locations where ground faults are likely to occur. GFCIs are an important safety device that can help prevent electrical shock and protect occupants. When correcting the homeowner's mistakes, be sure to follow these best practices. Firstly, disconnect the power. Always disconnect the power to the circuit you are working on before making any repairs or modifications. This will prevent electrical shock and ensure your safety. Secondly, use proper tools and equipment. Use only approved tools and equipment for electrical work. This includes insulated screwdrivers, pliers, wire strippers, and multimeters. Thirdly, follow manufacturer's instructions. Always follow the manufacturer's instructions when installing electrical equipment and devices. This will ensure that they are installed correctly and safely. Fourthly, inspect your work. After completing your work, carefully inspect it to ensure that everything is properly installed and connected. Check for loose connections, damaged wiring, and other potential problems. Fifthly, test your work. After inspecting your work, test it to ensure that it is functioning properly. Use a multimeter to check for voltage continuity and resistance. If you are not comfortable performing electrical work, it is best to hire a qualified electrician. Electrical work can be dangerous and should only be performed by someone who is trained and experienced. Hiring a qualified electrician will ensure that the work is done safely and correctly. When communicating with the homeowner, it's important to be clear, concise, and professional. Explain the issues you've identified in a way that they can understand, avoiding technical jargon. Emphasize the importance of electrical safety and the potential consequences of improper wiring. Be prepared to answer their questions and address their concerns. If they are resistant to your recommendations, remain calm and professional and explain the reasons for your concerns. It may be helpful to provide them with written information about electrical safety and the importance of hiring qualified professionals. In conclusion, dealing with DIY wiring disasters requires a combination of technical expertise, communication skills, and legal knowledge. By following the steps outlined in this guide, you can effectively address the situation, protect your business, and ensure the safety of your clients and their homes. Remember to always prioritize safety, follow code requirements, and communicate effectively with homeowners.